Hello everyone. Today let's solve the problem number 2. Add two numbers. Right. So what the question states here, we are given two non-empty linked lists. You can clearly see here. Let's come to the example one. This is example one. Right. So we have been given two non-empty linked list here. List 1, L1 and L2 basically. Right. List 1 and list 2. So representing two non-negative integers. Right. The digits are stored in the reverse order. So they have said that the digits are stored in the reverse order. So see here, we have 2, 4, 3. The digits will be saved in the reverse order means 3, 4, 2, 4, 6, 5. Right. So this is what they are trying to say here. The digits are saved in the reverse order and each node contains a single digit, and each node you can clearly see here. Right. So within the diagram, they have shown wonderfully here. Each node consists of the single value or the single digit. We have to add the two numbers and return the sum as linked list in the reverse order. So we have to add the two numbers. So here we have to add the two numbers and return the sum as a linked list in the reverse order. So we have to add the two numbers, that is fine, and we have to return the sum as linked list in reverse order. So we have to return the linked list in the reverse order, assuming no leading zeros except the number 0 itself. Right. We have to assume that it consists of no leading zeros except the number 0 itself. Number 0 itself. Right. I hope the question is completely clear, man. Right. So here you can clearly see we have 243 and 564. When you add this one, you get basically 807. 807, right? 4 plus 3 7, 6 plus 4 this one, 4 plus 6 10, and 1 carry here, 5 plus 2 plus this one as 8. We get 807, and we need to return the reverse, right? Reverse of this one basically, right? So here in this case, when we reverse this, we get 708. So we need to display this one in the form of output. The output that we get by summing up two lists, we have to return the output in the reverse order, right? Reverse order. That's what they have given in the question. Very simple to understand, right? So let's come to the example 2 here. We have 0 and we have 0. So this will lead to the 0 itself, right? So this is fine. So here in this case, third one, we have this one. So 1 triple 0, this will be 998. So basically we get here one this thing, when we reverse this one, we get this value, right? When we reverse 1 triple 0 triple 998, we get this one 8 triple 9 triple 0 1. So here we have only one number. When we reverse, if we keep that as it is, then it doesn't change. Basically the output will be 0 itself here in this case, right? When we reverse, basically it will be 0 itself, so output is 0. So I hope the question part is completely clear. Let's do one thing. Let's quickly discuss the approach, followed by the edge cases one by one, and then finally let's let's discuss the approach followed by the complexities, and then let's write the code. Initially, let's discuss the approach first. So here we have, let's consider this first example. We have 243 and we have 564, right? So first let's add 2 plus 5. This one I'm speaking of. First thing is, we'll be going with the linked list approach, the operations that are provided by the linked list. Basically this is a list question, right? So we will be going with the linked list, right? So the programming language, we are making use of Java. What are the operations that are provided by linked list? We'll be making use of it, right, to write the code. So just keep this in mind. We'll be making use of the data structure linked list. So here in this case, we represent these numbers 3 4 2. So we have to get the output in the reverse order, right? So first what we'll do, we represent this one reverse. So here we have got 3 4 2. Instead we represent this one by 3 4 2, right? Same thing goes with this one as well. We have got 5 6 4. Instead we will reverse and we will represent this in this format, 4 6 5. 4 6 5, right? First thing is, we have to add the 2 plus 5, this one 2 plus 5. So what we'll do here, when we add 2 plus 5, this one will be 7. There is no carry here, right? So this is nothing but the node 7. So this is nothing but node 7, right? So next we will add 4 plus 6 here. So this will be, we have carry 1. So we will represent this one by 0, and we'll go with the carry 1 here. We'll go with the carry 1 here, right? So step 3, we have to add 3 plus 4 7, and we have carry 1 here. Total 4 plus 4, it will be 8, right? So this is node 0 and this is node 8. This is node 8. Final result that we got here is 807. Finally what we have to do, we have to reverse this one. We have to reverse this one. right? When we reverse this one we got 708. When we reverse this one we will get 708. So basically the last step is reversing the number after the addition, right? So this one is fine. So the output that we got here is equivalent to the output that we have that they have showed for the example one. So our approach works absolutely correct in this case, right? Our approach works absolutely correct, right? So here this is nothing but here this is the reverse of 708. This is the reverse of 708, right? So our approach works absolutely correct in this case. So as we are completely familiar with the approach, now let's do one thing. Let's discuss the complexities and then let's write the code. So what will be the time complexity here? Overall time complexity would be big of max of n comma m here. So we can go with like this, because of max of this one n comma m. So the time complexity would be because of max of n comma m, because we are visiting the each node in both the lists exactly once. We are visiting the nodes in both the lists. We have to visit every node, right? We are visiting the node in both the lists exactly once. That will lead to the time complexity of big of max of n comma m, two lists, right? So what would be the space complexity? Same space complexity would be same as well, because we have to save in case we are visiting the each node. We have to save that one in the memory as well, right? So the space complexity would be this one, big of max of n comma m, because the output list size is equal to the larger input size. Also we will be going with plus 1 for the carry, right? So overall space complexity would be big of max of n comma n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of max of n comma m, right? So now we are completely familiar with the complexities. So as we are completely familiar with the complexities and the this one approach, now we are good to write the code. Let's start writing the code. First step here would be we'll be making use of the dummy head here, right? So we'll be making use of the dummy head just to simplify the result handling, right? So simplify edge cases or simplify the result this one list handling, we'll be making use of the dummy head. So I'll just go with here list node dummy equals new list node of 0. Initially we'll assign this one to the 0. We'll assign this one to the 0th index dummy head. So then we'll be going with the pointer to build the result list. So we need to build the pointer, right? So I mean we need to build the result list, sorry. So for that purpose we'll be going with the pointer, nothing but the current pointer. Here the same thing, list node currency equals, let's assign this one to the dummy. This one is fine. Finally we have to initialize the carry to 0, right? So we'll be making use of the carry. So this is fine. Now let's go with the main part. We have to traverse both lists L1 and L2, right? So let me write the simple if while loop here. Li should not be equal to null, or L1 not should not be equal to null, or L2 not equal to null, or carry not equal to 0. Then only we have to move forward. This is not Li, this is L1, sorry. So within this while loop, the first condition here would be, so we have to start with the carry from the previous step. We have to always start with the carry if we have to from the previous step, right? So this one, let me initialize or assign the sum to carry. Let's assign the sum to carry. This is fine. Let me come out of this one entirely. We have to add L1 value if it exists. Means here if L1 not equal to null, then within the if condition sum equals sum plus L1 dot val, and also L1 equals, let's assign this one to the L1 dot next. So this is fine. So we have successfully added L1 value if the L1 value exists. Basically let's come out of this one entirely if condition. So here we have to do the same thing with L2. We have to add the L2 value if it exists. So let me copy the same thing and make the necessary changes here. So let me paste it over here. This one, if L2 not equal to null, this one will be L2 value, and L2 will be equal to L2 dot next. So this is fine. Let me come out of this one entirely. Now we need to update the carry for the next iteration, right? For the next iteration, we have to update the carry. So carry we can just give like this. So equals sum divided by 10. This is sum divided by 10. This is fine. So after updating the carry for the next iteration, we have to create the new node with the this one current digit, nothing but the sum modulo 10, right? So this we can write it in this way. Current dot next equals new list node of sum modulo 10. This is fine. The next step is we have to move to the next node, means I'll just give here current equals current dot next. So this is fine. So this is next, not next. So this is fine, I hope. Yeah, this is fine. So let me come out of this one entirely. We have successfully created a new node with the current digit, nothing but sum modulo 10. We did, right? So in the previous step, the last two numbers, the last two lines I'm speaking of, this one 22 and 23, the line number 22 and 23 I'm speaking of. The final step is we have to return the result list, means we have to skip the dummy node. We just considered for the to simplify the test cases, basically to simplify the edge cases, or not the test cases, to simplify the edge cases, we discussed the dummy node. Now we have to skip the dummy node. We just have to return the result list, nothing but here in this case, let's go with return dummy dot next. This is fine. I hope this is fine. So let me format the code once and let me hit the run button. So here you can clearly see all the test cases are getting passed. I mean sample test cases are getting passed. So let me hit the submit button. Here you can clearly see all the test cases are getting passed, means the code works absolutely correct in this case, right? So the code works absolutely correct in this case. So let me nothing. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.